What do you do when you have this expression? You can do difference of perfect squares, yes. What else? So we probably want to find what x is. Or we could just bring the 4 over, right? X squared equals 4. And then either way you're going to get x equals what? Plus or minus 2. You remember this? Okay, what about this one? So let's try bringing the 4 over. What do we get? And then we do square root of both sides. And we have a negative number inside the square root. Thus the beginning of the new topic today. Long ago, someone decided this. The square root of negative 1 is equal to the letter I. So in specialist, we can go one step further. We can separate this into two things. 4 and negative 1. What's the square root of 4? 2. And the square root of negative 1 is?
Would it be plus minus?
Yes, it should be plus or minus. In the new topic, complex numbers, you have this I factor. I is equal to the square root of negative 1. Please copy it down. So a complex number has an imaginary component. And that's what this I represents. It's like a unit, I suppose. And anything with an imaginary component, so A is equal to 2i, this is a complex number because it has the I in it. A complex number has an imaginary component, and that imaginary component contains I, square root of negative 1. Let's try this one. B is 3 plus 5i. Which part of it is the real component? The 3. Which part is the imaginary component? The 5, or the 5i. Okay, so you can write this down as well. A complex number can have a real component and an imaginary component. The real component, there's no I next to the number. The imaginary component has an I. Alright, I want you to try and write these as simplified. These two, go. Square root of negative 25. Square root of negative 10. Using the information I just told you. So the first one, in here, there's a negative 1 times the 25. You obviously don't have to do this working out, I'm just showing you. The square root of negative 1 is I. The square root of 25 is 5. So you end up with 5. So this one here, a little bit trickier. Square root negative 10. What do you think we do next? Can we square root 10? No. So it's just square root 10 I. Okay, so from now on, in specialist, if you ever see a negative inside a square root, you have to convert it to that I. Okay, so it's different to methods. In methods, you would just say undefinable or doesn't exist, or however you want to describe it. Many mathematicians describe it different ways. Okay, so now hopefully you were listening before. Try this one. Write down the real and imaginary parts of these two. So we often call a complex number Z. So the real part of the first Z, or RE standing for real, is what? The imaginary part of the first z, 4. Okay, so you just write the coefficient of I. I'm just going to change this to a W. I apologize if you've already written it down. The real part of W is 0. The imaginary part of W is 0.25. Okay, getting a bit trickier. We've got I to the power of 10 plus I to the power of 7. So I'll just give you a heads up before you jump into it, in case it's not obvious. I squared is that times that, which is -1. So now you try and figure out that. So in case you haven't figured it out, there's a pattern. And when does the pattern repeat? No. First is I, then it goes -1, then it goes -I, then it goes 1, then it goes I, then it goes so every 4 it resets. So I to the power of 7 is -I. Very good. You figure out I to the power of 10. So I to the power of 10 plus I to the power of 7 is -1. Take I. And that is in the form A plus BI. Alright, so hopefully you get this little joke now. Alright, well, we're going to move on now. So we're going to start to add, subtract, and multiply complex numbers. So copy down the examples on the screen. You've got Z and W, both complex numbers. When we add them together, what do we add together? You add the real and the real together, and the imaginary together. Real plus real, imaginary plus imaginary. And you end up with that answer. Okay? Subtraction, you subtract the real, subtract the imaginaries. Pretty straightforward. Then you can do scalar multiplication. So you got a complex number Z, 2 times the complex number, multiply both parts by 2. Yeah? The multiplication is the tricky bit. So we've got 2 imaginary numbers and we're going to multiply them by each other. So you're going to use, I don't know if you've ever done FOIL. First times the first is outer times the outer, inner times the inner, 12i, last times the last, 18i squared. Okay, so now we've got to simplify that. So the 12 i's add together. But what's I squared? -1. So this becomes -18. So the final answer is -10 plus 24i. Okay, so the multiplication is a bit more complicated because you'll usually have an I squared at the end, which you've got to convert to -1. Because the square root of -1 squared is -1. Okay, any questions?